Okay, today is August 27th, 2017, and right now at 11:30, we have a temperature of 79 degrees in the foothills of Los Angeles. We had hot temperatures today, right around 99 degrees. It's going to be over 100 tomorrow, and we had clear skies. We had some cumulonimbus development over the mountains today. And that's from some surface low pressure. We'll show that on the pressure charts here in a minute. Right now we're looking at Harvey, which is stalled over the Houston area. And we can see that a transmitter is actually working on this system. There's very little counterclockwise rotation here in the center. We have a lot of manipulation right in this area. And we have a lot of clockwise rotation over on the east side of this storm, which is winding a lot of moisture back around. This storm has done a lot of damage, and the forecast is for this to move back out over the Gulf of Mexico and rebuild. So we can see what's happened here. There is a rectangle. We've got a transmitter focusing right on top of that storm. We have some very dark and tan areas out here. That indicates dry conditions, as we can see here on the scale. Let's look at some of these other maps. We have the infrared map. We can see the red, it's intense weather. This high pressure being forced into this area will cause a lot of tornadic activity, which is what we've been hearing about on television all day. And we can see a little blast pattern here, but once again, it's nothing, it's not sufficient to break the storm down. This has been allowed to move in, and now it's stalled in place. Okay, now here on the southeast map, you can see a lot of clockwise rotation. We have a disturbance out here with, I think this is a 30 or 40% chance of hurricane development in 2 days. Here's Harvey over near Texas. A lot of high pressure in this area. That's what's causing all this clockwise rotation. All right, let's refresh that one. This is the IR map, the infrared rainbow map. Notice the evaporation pattern right here where the pen is. Everything is evaporating into this zone of high pressure, which is causing all the clockwise rotation. Because of this developing storm right here, we have a hurricane in progress, building, 30% chance in 2 days right there. So there is an effort to maintain high pressure between Harvey and this thing over here. All right, let's refresh this one. And we have the southwest water vapor map. Now, right here, we have another supercell, which is being superheated. And we can see that pressure wave shooting out to the northwest as that area is imploded. This thunderstorm is imploded with microwave. The convective process is stopped. The color change is dramatic. We go from a magenta down to a light turquoise down here on the scale. And we have a pressure wave. All within just a few hours. So this is not Mother Nature. That is a transmitter superheating this area. This water vapor rapidly expands. You know, 101 talks about the tea kettle. He's got his tea kettle out every one of his videos. He's, you know, talking about how to boil water and how it expands and all that and generates airborne water vapor. Well, same thing's happening here. We're heating water very rapidly, and we see a pressure wave move out, and that's what's happening there. We have the color change, the diminishment. These dots are pretty easy to connect. There's not too many ways this can be done. It can be done with laser as well. But a microwave is very effective at heating water vapor specifically. Now the IR map is showing the same pattern and the color change. We see that area implode. The convective process is completely wiped out. Come back to that. All right, let's take a quick look at the pressure maps, because the pressure maps explain a lot about what's going on. We have the surface pressure map, and Harvey is shown right here. We have a surface low. We have a lot of squiggly lines. Notice these isobars are all squiggly. They should have smooth, sort of a laminar type flow. These squiggly lines demonstrate turbulent flow, and that is because of the descending air that's being forced into this area. And over here as well, we have a surface low right there over Nevada and California at the sea level. Now, if we look at the 500 millibar map, we can see we have a high stacked right on top of that surface low. And look at the squiggly lines here. That's a mixture of high and low pressure. This high is descending air. It's being forced into this area. We've got a manufactured heat wave going on right now. As I say, it was 99 today. The last couple of days it was nice and cool, and it abruptly heated right up. And tomorrow we're expecting, I think, 103, and then on Tuesday I think it was going to be like 105 or 6. And we can see what's happening right here. Look at these squiggly lines. There's nothing normal about that. That indicates a mixture of high and low pressure all mixed together. And look at these nice smooth lines here. This is what everything should look like with no manipulation. But look at down here. We've got a closed low at 500 millibar level, 18,000 feet. But at the 30,000 foot level, the 300 millibar level, we see nothing here but these squiggly lines. So we do have some manipulation. We have high pressure in this area. Everything is moving clockwise. We have a very sharp edge here. That's odd. That's where this high pressure is, right here. That's blocking any eastbound movement of this storm. And then we have high pressure up here, which is not really depicted properly, and that is preventing this from moving north towards this low up here at the 300 millibar level right up here. So there's a lot of manipulation going on. And once again, we have some close-up views of Harvey right here. And we see very little rotation in that center as that high pressure is forced into the center of that system. And that will cause tornadoes and wild weather out here over the Louisiana and up here over Texas. All right, let's take a look at the, I have some screen images I've saved. This is from July 13th, 2017 over Mexico. This demonstrates the power of the WSR-88D microwave Doppler, otherwise known as NEXRAD. This is a very straight edge. This goes on for a couple hundred miles. We can see the envelope here. Fits in very, very well into that contour. That's pretty nice right angle right there. Again, this was taken on July the 13th. Screenshot. This demonstrates the power of those microwave transmitters. Look at these supercells all chopped up. Let's look at the next map. Right here we see, this is a zoomed out view of the same time. You see the Mexican border up here. And look at this straight line. This moves all the way from well up into Arizona, north of Nogales, all the way down to La Cienega down here. And look at that straight edge. So we can get an idea of the power of those Doppler radar transmitters that are transmitting in the 2.49 gigahertz range. right, now let's look at the Doppler map for August 24th. This is Harvey out here, just off of Brownsville. We can see that some minor effort is being made to break this system down. We can see a scatter pattern that all triangulates back to Brownsville right here. You can see the scatter pattern, the lines. I don't know if you can see that very well. Let's get the camera lined up. Okay, so all these lines here converge in Brownsville. There's a transmitter in Brownsville, which is known as KBRO, like I mentioned in the previous video. But this is a half-hearted attempt. We just saw the power capability down in Mexico. This transmitter could have done the same thing and nipped this thing in the bud as it was moving north. Here's the center of that storm. All right, let's take a look at some of these other maps. Here is the western U.S. water vapor loop. Let's go back one more here. Northeast Pacific water vapor loop. We have high pressure installed. We just looked at that on the pressure maps. This cell here is being blown apart, superheated. Take a close look at that. This upper level low is being steered by this installed high pressure. None of this monsoonal moisture is going to move north. Here's another shot. See that thunderstorm there being superheated. See that pressure wave moving out. That's not Mother Nature generating that. We can see the color change as well. Goes from a magenta down to a light turquoise. We see a lot of diminishment after that area is superheated. North Atlantic water vapor loop, we see the clockwise rotation. And we've got high pressure on the north side, that stalled it. And we've got high pressure over here on the west side here. So on the north and the west, we've got high pressure. And we've got high pressure over here, separating these two. This developing hurricane right over here, which is a disturbance right now. Here's the water vapor map for the Texas area, the south central map. You can see a rectangle formed in here, right there. And that is preventing the counterclockwise rotation. But what this system needs is to be pinpoint targeted with a microwave, just to superheat this and wipe it out. That's not being done. This system has been allowed to create a lot of damage. Notice all the high pressure right here. So this is blocked to the north. You see this big channel right there. And out over here. Can't move west and it can't move north. And of course it can't move to the east because of all that swirling high pressure that I was just showing right here. Got high pressure in this area to separate these two items. So it's stalled in place, just like what happened with Hurricane Joaquin, which I covered back on September 30th of 2015. You should check out those videos. Go back to September 30th and watch all the videos up to September 5th. That was a Cat 5 hurricane that was stalled right off of Florida here. And South Carolina got soaked for 3 days straight. And they look just like Houston does today. That hurricane was stalled. It was going to move into the Gulf. It was pushed back. Nobody knew what was going to happen. And of course, the El Faro ship captain didn't know what was going to happen. He sailed anyway and got caught in the middle of a Category 5 hurricane. So you can see all that on those videos on this channel. Check that out. We're running out of time here. I'm just going to go ahead and leave it right here. And we'll do another one. Try to do another one tomorrow. And that's it.